sheet, did you get anything else? In the solution sheet that I have, option B is the right answer.
Yeah. Just I am checking, sir.
Yeah.
Which week assignment, sorry, this one?
This is
week 3 or week 4?
This is week 3, question 7.
Okay, okay. I am checking, sir. Just a minute.
Yeah.
So option B is correct.
Option B is correct, sir.
Oh, okay. Yeah, yeah.
Sir, at the same time, the previous question, what you have said regarding neighborhood, the answer has been given as 3/4, sir. Someone has asked, na, what will be the neighborhood overlap of the HB connected between V0 and V2? It is there in the assignment, sir. Week 3, sir.
Week 3, which one?
Oh, find the neighborhood overlap of the edge connecting between V0 and V2 in the given graph. It has been given as 3/4, sir.
In the chat box, you mean? The one?
Yeah, sir. Yeah, chat box.
In the chat box, is it given 3/4? So someone has also posted. It's given as 0.5 SB.
Excuse me, sir.
Yes, sir.
Yeah, go ahead.
May I share this solution of this question?
Which question? This neighborhood
question
over.
Number which we have discussed right now.
This betweenness, are you talking about?
Yeah, about the betweenness, sir. May I share?
Yeah, go ahead. Well,
yeah, just a minute, sir. Is it visible, sir?
Yeah, I can see it. So
yeah, please say question number 10.
Okay.
Answer is D.
What can I think this is E1 has higher betweenness than E2. So there is something wrong with this question. So the answer would be B. So if it always arranges in descending order, and some people just mentioned also that it is B. So there is like in the given Newman algorithm, if you go to this timestamp that they have given, you can see there that it arranges in descending order and then it removes. So in descending order means
but at that time it is showing, sir, right answer key. This is right answer key. Solution of the assignment week 3.
So in the previous year's question, they have the same question in week 3 question number.
This one week 3 assignment, sir.
Yeah,
week 3 assignment. You can say assignment
but
number 3.
In the previous year's quest, like
not previous year, this year, sir.
So I'm saying that in previous year they had the same question and where the answer they have given was B, and now they are in this year they have given as D. So you should ask.
Just a minute. You can say this social network NPTEL January 2022. It is already mentioned on all solution of the assignments. Okay, it is not old. It is currently session.
But if you see,
are you getting?
Yeah.
Are you getting, sir?
So so I am asking you. So what do you know about the Girvan-Newman? Sorry. So in the Girvan-Newman's algorithm, do you agree or not that the edges get removed according to the descending order of betweenness? Do you first agree with that or not? First, you tell me. In the Girvan-Newman algorithm, if you go to this lecture and if you study this lecture, what do you see? In which order does the edges get removed? What do you think? So anyone can answer. So what do you think, in which order the edges get removed?
Descending order, sir.
Yeah, so if it is removed in descending order and if E1 is removed after E2, what does this mean? That E2 has higher betweenness?
Yes, sir, you're right.
That
Yeah,
is the answer which is given by the accepted answer, sir.
so so
When the
it
scoring
must
has been released, they have given that the accepted answer is as you said, sir. E2 has a higher betweenness than E1.
Yes, sir, this answer key is wrong.
yeah, so I think that settles the matter.
Okay. Okay,
Yeah.
sir. Okay, thank you.
Yeah.
Yeah.
Sir, can you please share the same screen? The before question, sir, neighborhood,
Okay, I'm
whatever you have
sharing.
shown right now. Please
Okay,
share, sir.
yeah, I'm
But that the
sharing.
calculation is 3/4 we are getting, sir. Is it 3/4 or 3/6? I am in doubt.
Wait, let me share the screen. So, okay, so
This
wait.
is, sir, the person who has shared right now
Yeah, I'm
regarding
open.
the
Okay.
answer key, sir. Answer key. I don't know the
Yeah.
person name.
Let me go to the chat box. I think it's there in the chat windows. So, mm, this
Yes, sir. That is
question.
what. That's what. Yeah.
So here they are asking about the neighborhood overlap of V0 and V2.
Yeah.
So how many mutual friends does V0 and V2 have? So V0 has V1 is a mutual friend, V4 is a mutual friend, and V3 is a mutual friend, right?
Yeah.
And total number of friends that V they have is, so V0 has 5 friends. So from V1, 2, 3, 4, 5, that is 5. And V2 has 1, 2, 3, 4. So V2 has 4. And that would be total of 9. But we are counting the mutual friends twice. So if we remove the 3 mutual friends, that is 6. So they have total of 6 friends, and the mutual friends is 3. So neighborhood overlap should be half in this case. If you go by the formula of A intersection B and A union B, so by that it should be half. So you are telling it is 3/4.
Yes, sir.
So how is that 3/4 coming? Did
Sir, in
anyone
the
of
assignment solution key, it is given as 3/4, the correct answer. 1 by
Sir, can
2
I
is
answer
not
for
even an
this?
option there.
if someone wants to explain this? So go
Yeah.
ahead.
So actually, the question is like that. The age is considered, not the nodes. V0 and V2. The single age is considered here. So the common between this age are V4, V3, and V1, which is 3, and divided
Okay.
by total possible friends near them, which are V4, V5, V3, and V1. So the correct answer is 3/4.
Okay, so they are not considering each other
Yeah,
while.
yeah. The question is asked about an age, not about vertices. That's why.
Okay. So okay, so leaving V, like when counting for the total number of friends, V0 is not considering V2 and V2 is not considering V0. Leaving
Yeah.
them aside, what is the other friends? Okay. So I think that would, if they have given this as the answer, I think this would be the so when computing neighborhood overlap, you don't consider the friends who are present on the edge that you are considering. So for this question, if V0, V2 is the edge for which neighborhood overlap has been asked, so don't consider V2 as the friend of V0 while computing the total number of friends, and V0 as friend of V2 while computing the total number of friends. So I think that is how you can calculate it. If they
Yes,
have
sir.
given, so you can go ahead with this, like you mentioned.
Sir, then
Yeah, go ahead.
Can you repeat the answer? How 3 by 4 is achieved, sir? I'm in
Okay,
doubt still.
okay, I'm drawing that figure over here. So you have V0, you have V2. So you have this edge and they have this mutual friend, say V1. They have one over. So I take a look. Just one minute. V4, V3, and this is V5. So while computing the betweenness of V0, V2, so you're computing betweenness. So for intersection of V not intersection V2, what you do is select this. Uh, Let me put it on the. So you have this mutual friend that is 3, 1, 2, sorry, V1, V3, and V4. So you get 3 over here. But while computing the union of it, V0 union V2, what you do is for you do not consider. Let me figure it. So while computing the union, you consider V5, V4, V3, V1. That is all the total number of nodes that are connected to this edge. So that can be reached from either V0 or V2, but you do not add take into consideration V0 and V2. Therefore, this would be 4. So you consider all the nodes except the one that is present on the edge. So that is how you get the ratio 3 over 4. You
Thank you,
get
sir.
it?
Thank you. Thank you,
Mm,
sir. Thank you.
Yeah. Someone has raised their hand. If you have any doubt, you can unmute yourself and ask, or we can move on to the next question. All right. So let us move on to the third question from week 3. So it is which of the following statements are true with respect to this edge x in the given graph? So you have this edge between A and B. So you have 3 options. Is it a weak tie? Is it a local bridge? Is it a strong tie? So it is a weak tie because A and B do not have mutual friends. No mutual friends. It is a weak tie, and weak ties are local bridge and vice versa. So if one is correct, two is and if local bridge, so if I it is not a strong tie because so one is correct, two is correct. And if it was a strong tie, then B and C would also have been friends by strong triadic closure. But that is not the case. So option 3 is incorrect. So the right answer is it's a weak tie and it is a local bridge. So option C is the right answer.
Excuse me, sir.
Yeah, go ahead.
For a strong tie, there must be mutual friend of A and B. It means a triadic closure must be should be
Yeah.
exist.
Yeah. Strong triadic closure property must hold. So if X was a strong tie, then at least C should have been a friend, or maybe D could have been a friend in either or. Yeah, so if these two were friends, then it probably could have been a strong tie. But since they are
Yeah,
not
if we
present,
connect if we connect C to B or D to A,
hmm,
it means
hmm,
that must be exist a strong tie between A
uh,
and B.
yeah, you're right.
Okay, sir. Thank you. Thank you.
Yeah,
Excuse me, sir.
yeah, go ahead.
So I have posted a similar question in the chat box. Could you please check that?
Okay, let me see. What is the number of bridges in the network? So,
So is
okay.
it 1 or 3?
Can you repeat what you just said?
Is it 1 or 3 answer for this question?
So there are, wait, so let me share it on the screen for everyone. So what is the number of bridges? So for if I consider a local bridge and a normal bridge. So for normal bridge, if we remove that, the graph becomes disconnected. So here, if we look at the graph, if we remove any particular edge, does this become so there are, I think there are no strong bridge in this example, but if we take number of local bridges, so for local bridges, we'll have to see uh, 9. So you said that the answers are 1 or 3. So if you tell me, if you remove, so which edges are you considering as bridge when you say that?
So actually it's the question from that question corner, like ask a question tab
Okay, so
from there. So the
here
options were 1, 2, 3, and 4.
1, 2, 3, and 4. So I in this case, what I'm seeing is that almost all, if you take any edge, so any two pair of nodes, so they all any edge that you take, they always end up having a mutual friend. If you take 1 and 2, their mutual friend is 3. So like that, if you take 5 and 6, you have 7. So if you remove this 3 edges that connect 5, 6, and 7, that could lead to a disconnected component. So in that way, that can be a bridge, but the by the definition of local bridge, they do not have mutual friends among themselves. So there is no strong bridge that I can see directly from this graph, that if you remove it, it will become disconnected. But local bridge by definition, so can you point out any edge that you think is a local bridge according to you?
So actually I was confused, so I asked. So,
Uh,
but I think options might be wrong. You seem to be right.
Yeah, so every edge seems to have a common mutual friend. So I don't think there is any bridges over here, unless you can, if you remove this between 5, 6, and 7, then they will become disconnected. Mm, No, I don't. Okay.
So basically 5, 6, and 7 makes a triadic closure. So there
Yeah.
can't be bridges, right?
Yeah. So even if you consider uh, between 6 and 7, so they have a mutual friend at 5. Any two edge all have a mutual friend. So all, so did they say anything about the strength of these ties, like in the graph that they have shown? So do they give any information about, like I can see that the edge between 2 and 3 is much more solid compared to the other edges. Does that have any significance, or is it of no significance?
No, sir.
So then I don't think I can see any bridge over here.
Yeah.
Okay. Okay, so we'll proceed with the discussion. Okay, so coming back, we have we proceed on to week 4 question. So in week 4, you have Raghavan is a warden in the Ganga hostel. He observes the following graph of friendship between BTech and PhD students of the hostel. What is the homophily of the network? So homophily is basically homophily H is basically 1 minus P. So where P is the probability of an across edge being present. So higher the probability of friendship between BTech students and PhD students, lesser is the homophily. Homophily is basically the measure of how well birds of same feather are connected. So BTech student, how well BTech students are connected among each other, or how well PhD students are connected among each other. If the homophily was high, then there would be more connections among BTech students and among PhD students than connections across them, and a low homophily would signify that there are more connections across than among the students. So how we compute this probability P is basically P is calculated as number of across edges, so by expected number of across edges. So for that, we first find out probability of an edge being an across edge. So you have, I think, 11 students here, 11 students here. So mm, for across edges, so it would be pairs like B1, P1, B1, P2, and so on. Let's say B11, P11. So these are the pairs that we are looking for. So represents BTech students and P represents PhD students. So uh, for that, how many such pairs exist are basically 11 cross 11, and total edges would be 22 C2. So 22 into 21 over 2, that is 11 into 21. So the probability of an edge being an across edge, so 11 cross 11 edges are across, can be across edge, and 11 into 21 are the total number of edges. So this is roughly around half. So this 11 11 cancels, and 11 over 21 is near to 11 over 22, that is half. So now how to find expected number of edges? So let us call this E. To find E, what we'll have to do is expected number of edges. So let's say uh, X be a random variable denoting total across edges. So what it does is X is the sum of x1 plus x2 plus x 16. Why 16? I'm explaining. So what are, so you observe in this graph that is given. So there are total of 16 edges drawn in this graph. And what we do is each of these are a random variable that takes 0 if not an across edge, and 1 if across edge. So these are basically indicator random variables. So you have 16 of such indicator random variables, and if you add them together, you get the total number of across edges. Now, if we take the expectation of it, expectation of x, that is the expected number of total across edges, would be e of x1 plus e of x2 plus e of x16. And expectation of an indicator random variable is basically its probability. So probability, we call this probability of an edge being an across edge. So that is half. So you add p plus 16 times. So that is half into 16, that is 8. So expected number of edges across is 8. So what uh, okay, this probability, let us call it as p dash, to not to confuse with the homophily p. So this is p dash, and therefore p, that is the number of across edges, that is 4. And what is the expected number of across edges is 8. So this is half, and homophily would therefore be 1, 1 minus half, that is half. So the homophily of this network is a, half. Okay, coming to the next question, that is question number 6. The probability of John and Eva not being friends, given that they have a common friend, is 0.8. What is the probability of them being friends, given that they have 8 common friends? So let us call this 0.8 as p. So now we are asked probability of uh, J and E being friends. That would be 1 minus probability of J and E not being friends. So probability of J and E not being friends. So let us call it by this cross. Cross means they are not friends, given that they have 8 mutual friends. So we are denoting F1, F2, F8. So they have these 8 mutual friends. So how we can write this as probability J and E not being friends, and they have uh, J and E not being friends, and uh, they have friends F1, F2, F8, and probability of F1, F2, F8. Probability of J and E making friends with F1, F2, F8. Now we assume that they are independent, that they made friendship with F1 independently of making friendship with F2, and so on. So probability of J and E. So this upper term can be written as J and E not being friends into and being friends with F1 intersection J and E not being friends and friends with F2, and so on till J and E not being friends and friends with F8. So, and the denominator can be considered by independent event, they can be broken down. So what you get is basically probability of J and E not being friends and being friends with F1 over probability of friends being F1 into J and E not being friends and being friends with F2, and probability of them being friends with F2 until F8. So this term that probably, if you see that probability of John and Eva not being friends given that they have a mutual friend. So this term over here can be written as probability of J and Eva, John and Eva not having friend given that they have friend F1, a mutual friend F1. And again the same things, J and E given F2 till F8, and this is nothing but your P. So it's P to the power 8, and P was 0.8 to the power 8. And what we actually have to find is 1 minus 0.8 to the power 8. And if you compute it, it would be this option A, 0.83. 0.83. So this is the right answer for this question. So what is the probability of them being friends if they have 8 common friends? So that is 0.83. Coming to question number 7. Ram and Raghav both are parts of a Royal Cricketing Club. They meet at the club and gradually become friends. So what is this phenomenon known as? So this phenomenon, so you have this Royal Cricketing Club RCC, and you have Ram, you have Raghav. So they came to the Royal Cricketing Club and then they became friends. So this is concept is known as foci closure, that this is the foci. So the Royal Cricketing Club was the foci that brought both of them together, and since they became friends, so there is a closure. So this is known as foci closure. So if it was a membership closure, then it would have happened like this. So you have Ram, you have Raghav, and you have RCC. So let's say Ram goes to RCC and Ram is friends with Raghav, and then Raghav starts going to uh, RCC as well. So this is membership. So this is membership closure. So Raghav became a member of RCC because uh, of Ram being connected to RCC. So this is the concept of membership closure. And for triadic closure, you need one more person to be present. So you have Ram and Raghav, and let's say another friend A. So let's say Ram and Raghav are friends, and Raghav and A are friends. So Ram and A will also become friends. So this is triadic closure. So in this concept, in the question that is asked, foci closure is the right answer. And social influence is not related to closure, but it helps in formation of the closures. So in especially in the membership closure and the triadic closure, social influence plays a part. So Raghav was friends with Ram, therefore Ram influenced Raghav to join RCC. And here Ram is friends with Raghav and Raghav is friends with A. Therefore, Raghav influenced both A and Ram to become friends with each other. So that is the case of social influence.
Excuse me, sir.
Yeah, go ahead.
Yeah, please just repeat last triadic closure one more.
So in triadic closure, you need three. person. So RCC is an organization. So in when you talk about triadic closure, you talk about three same kinds of nodes. So if you're talking about people, so here Ram and Raghav are two people. So you consider one more person, A. Let's say A. So where Ram is already friends with Raghav, and Raghav is already friends with A. So now triadic closure happens if Ram and A become friends. That concept is known as triadic closure.
It means in triadic closure there must be third person
Yeah, yeah,
uh, in instead of a club.
yeah, right.
I am right, sir?
Yeah, you are right.
Yeah, yeah. Okay. Thank you, sir. Thank you.
Yeah, yeah. Coming to week 8, some questions from week 8. So this is the Schelling's model. So in the given situation with threshold t equal to 4, that is the minimum number of similar neighbors. So uh, t represents the threshold, and what it means is the minimum number of similar neighbor. Which node is not stable? So which center node is not stable? So we'll have to look at this center node in all the 4 cases. So in if we look at option A, the center node is green and it's similar. How many similar neighbor does it have? Is 1, 2, 3, and 4. And t equal to 4. So this is all right. So this is stable. If you come to option B, center node is green. How many similar nodes it has? It's 1, 2, 3. So this is not stable. It needs one more similar neighbor at least. Coming to option C, the similar neighbors are 1, 2, 3, 4. So this is also stable. Coming to option D, the center node is red and the similar neighbors are 1, 2, 3, and 4. So this is also stable. Yeah. So that which is not stable, they ask. So this is option B is the right answer for this question. Option B is not stable.
Excuse me, sir.
Yeah, go ahead.
Sir, could you please check the chat box? I have put some similar question to this.
Okay, so if T is 25% in the Schelling model, the minimum number of same type of neighbors of a node should have in an 8 cross 8 Schelling model is the minimum number of same type of Schelling model is so it should in a 8 cross 8 is basically like this. So in an 8 cross 8 means you have this center node and you have 8 surrounding node around it. So in this case they are asking 25%. So for what is the minimum number of same type of neighbors? So it's 25% of 8, that is 1/4 of 8. So it should have minimum of two similar neighbors.
Okay, sir, got it. Thank you.
Yeah. If a
Excuse me, sir.
yeah, go ahead.
Excuse me, sir. In a previous question, I have one more doubt.
Okay.
In yeah, in this one, yeah, yeah.
Yeah.
For example, like which is a stable or not stable
Yeah.
uh, according to the scaling model.
Hmm.
So we have to count in 8 cells position of the ball. For example, like with the same colors. Like for
Yeah.
example, in a case, middle ball is for example, like in case of green, it means we have to find out surrounding of center of this point or any position in the cell.
Uh, no, not only its neighbors. So that is the up, down, left, right, and the diagonal ones as well. So here in let's say option A, you have one green node at the center. So
And
simi
t is equal to 4. It means we have to find out the at least 4 neighbors of the same color.
Yeah, right. Then this node is center node is stable.
As I think A part, according to me, that must not be stable.
Why?
If we count neighbor of the center point, it means we can consider two position and four position,
So you can consider
not
one and
one,
three.
not
So
not one and three, not
so
one and three.
in the 8x8 shelling model, you considered the diagonal as well. So it is not mentioned. So in this grid type of structures, if they do not mention that you have to consider only the up, down, left, right, you can consider the 1 and 3 positions as well. So in addition to 2 and 4, you consider 1 and 3 as well. So if you go by like that, then I think none of the options would be correct. So none of them have all the four uh, s- same colored neighbors. So it is usually in this grid like structures, then diagonal elements are also considered.
We have to include it, those diagonal
Yeah,
element
yeah,
also.
yeah. If it is
Okay, sir.
explicitly mentioned that only the top and top down and left right are your neighbors, then you considered like that. But if nothing is given and a grid like structure like this is given, you consider the immediate diagonal neighbors as well.
But in previous question, sir, we have done, for example, like according to the definition of a scaling model, B option is the right answer. It means it means that is a stable.
No, no, B is unstable. B center node is green and green has only three similar neighbors. So it is below threshold. So
Okay,
it is
it means
unstable.
if there is a center point, it means with having the green color, it means its all neighbor must be with the same color.
Yeah, so like at least four neighbors should be of same color. So that is greater than or equal to four.
And doesn't matter location wise.
No.
Okay, sir. Thank you.
Okay. Coming to question number 8. If a country A is at war with B, so let us draw uh, A and you have B and A and B are at war with each other, so there's a minus sign to denote that they are not friendly. And let's say you have this country X that has come, and it is saying that X has good relationship with both A and B. What would be the stable situation for country X? So such a closure, such a triad is unstable because one of these plus will eventually turn into minus because x is friends with A and X is friends with B, but A and B don't talk to each other, so X would be in a pressure to choose either A or B. So if X helps B, then A will uh, not be a friend with X anymore, and similarly if X helps A, then B will not be a friend with X anymore. So either one of this plus will go to minus. So here A and X is plus and B and X is minus. So option C can be a right answer, or option D can also be a right answer. So both C and D are right answer. So one of them would change into plus and the other would remain, one of the plus will go to minus. So in both of these cases that can be seen, and hence both are right answer. So since I have come to this question, so let us just recall the various types of triads that can exist. So if I draw a triad like this one, so you have plus plus plus. This is stable. You have a triad like this where it is plus plus minus. This is unstable. And minus minus plus, this is again stable. This is known as friends, enemy's enemy becoming friend. And if it is minus minus minus, this is also stable. It remains so sorry, this is unstable. So this is where it one of them would become uh, enemy become friend. So one of the minus is likely to change into a plus. So these are the four types of triads that usually occurs. Okay. Coming to week 6 questions. So what does a Google PageRank algorithm uses? So this is a simple question. So it basically uses option D is the right answer, where it uses a web graph and random walk on that web graph. And that's how it computes the page rank of the various web pages. So this is a straightforward question. Coming to the interesting question. So you have initial page rank of each node is 1 by 4 in the given graph. What would be the page rank after one iteration? So what happens is that initially uh, 1 by 4, 1 by 4, 1 by 4, 1 by 4. What happens in after the first iteration would be C for A. So A distributes its page rank, what it had 1 by 4 and it distributes it to its neighbor. So 1 by 4, the the existing 1 by 4 is gone, but now A receives some page rank points from the its neighboring node. So who does A receive points from? So it receives this entire page rank from D. So D has no other outgoing nodes. It goes only to A. So A's page rank after one iteration would remain 1 by 4 because D gave it to A. What about B? What would happen to B is B gives away its 1 by 4 but receives from A and C. So what it receives is half of 1 by 4 that A gives away, half of 1 by 4 from A. So let me put it on the edge. Here it receives half of 1 by 4, that is 1 by 8 from A, and from C has no other outgoing except to B, so it gives the entire 1/4 to B. So B's page rank becomes 1/8 over 1 plus 1/4, so 1/8 plus 1/4, that would be 3 over 8. So B's page rank becomes 3 over 8. For C, C receives half from 4, that is 1 by 8, and it does not receive from anyone else. So C's page rank would be 1 over 8. And as for D, D receives the entire page rank of B. B does not give it to anyone else except D. So D's page rank would be 1 by 4 uh, after one iteration. So they have asked for only B and C. So B's would be 3 over 8 and sorry, C's would be 1 over 8. So option A is the correct answer for this question. So for just to make it a general statement, so you can compute uh, this page rank in this fashion also, or you can construct a matrix like this. So how you construct the matrix is like this. So you have a matrix and you have the page rank. This is the page rank of it. So it was initially 1 by 4, 1 by 4, 1 by 4, 1 by 4. And this is the, you get, this is old page rank, let me see. This is P old and this is P new. Okay, so initially you have, so what this first element denotes the new page rank of A. So page rank of A is basically comes from which are the nodes that are pointing to A. So the nodes that are pointing to A are only D. So D is the, it gets the entire page rank of D. So 0. So this is how you get 0, 0, 0001. For B, for node B, what it gets is it gets half of page rank of A and full page rank from C. This is how it coming to up for node C, it gets only from A. So for node C, it gets half of A because A gives it to B and A gives it to C. So it would be 0, 0, 0. And for D, for node D, it gets the entire page rank from B itself. So this is the Markov matrix that gives you the page rank after one iteration. So this is a Markov matrix and and eigenvalue, eigenvector corresponding to eigenvalue equal to 1 is the ultimate page rank, that is the converged page rank that you will, that would be the uh, page rank of the entire network. So if you can construct M and find its eigenvector corresponding to eigenvalue n, so you don't have to carry out these iterations every time. It would straight away give you the page rank of what the page rank of this graph would look like. So the challenge is to create this matrix M. So in what Google does, it does not create this uh, matrix M, because for to create this matrix M you need to have an entire web graph, the details of the entire web graph at your fingertips, which it doesn't. So what it does this random walk. It visits one node and then hops to a random neighbor, and from there it goes to a random neighbor and it keeps distributing points, and that is how it finds page rank. But if you have a smaller network for which you know what the structure looks like, then you can construct M and then you can directly find out the page rank without doing any iteration. Okay, so coming to the next question.
Excuse me, sir.
Yeah, go ahead.
Sir, could you please check the chat box for page rank questions? I have put 2 questions similar to this.
Okay. Mm, You have, okay. Wait, let me share it first. So you have this for the uh, so the two images are two different questions, right? Or
Yeah,
the
but
same?
the figure is same.
Okay, so for the given network age, what will happen, say after 10 iterations of PageRank update for the initial value of 1 by 3 of for every node in the network? So what happens is that uh, value of at A steadily increases, value of A steadily decreases, C steadily increases, B steadily decreases. So what would happen is that if you take node A, so it receives PageRank from B and it gives away to B and C. B receives the entire page rank of A, and C is only at the receiving end. So C does not give it to anyone else. So here the value at C is steadily, for the page rank of C would steadily increase, I think, because A and B would distribute points among themselves, but ultimately they will give it to C because C does not pass it on to anyone else. So C's page rank would keep increasing.
Okay, so
Right.
so but actually when I do it in the spreadsheet, like what is
Okay.
taught in the lecture, the answer uh, the answer for this becomes option number B. The value at C steadily decreases.
So can you share your screen by and
Actually, so I
okay.
need to search that. Can I share it after the lecture at the end of
Yeah,
it?
yeah. Okay.
Okay.
Yeah, then we can see it together. Okay.
Yeah.
You can coming to the next one. Coming to the next one, consider a graph G that the same graph that you showed. Which of the following is true for the graph? Converges with all points in node C, converges 0 points in node C, converges with maximum points in A, B. So since C does not share its page rank, so ultimately the page rank of A and B will accumulate towards C. So I think converges with all points in node C. Option B is the correct answer, I think.
Okay,
If
sir.
yeah,
Yeah.
Yes, sir, that is right. Converges with all points in node C. That is right.
okay. Coming back to our discussion. So in a random graph with n nodes, to visit all nodes in a random walk, the number of nodes required to be travel is. So empirically, it has been observed that if you do this random walk with n nodes, you'll have to traverse n log n nodes before all the nodes are traversed. So this is what Google search does. So it traverses it takes n log n complexity to create the web graph and generate the page rank. So the answer is D, n log n. Okay, coming to week 7. What's the density of a cluster? So basically the density of a cluster is the fraction of nodes that are present inside the cluster. So option B is the right answer. So D fraction of nodes are present inside the cluster. So if you have total number of friends, so you divide it in friends who are present inside the cluster and friends who are outside the cluster. And if you take the fraction, so D fraction of the nodes should be present inside the cluster, then the density of the cluster is D. So someone had asked a question about cluster density also. Let me go back and check. Hmm, yeah, I can't see any. If someone had asked, can you just repeat your question or um, okay. Yeah, so as we had asked, what is the cluster density of? Wait, let me share the screen. So they are asking what is the cluster density of each of the 4 node cluster. So you have this 4 node cluster A, B, C, D. So if you consider A, so number of friends inside the cluster to total number of friends. Wait, so I won't be able to write over here. So what would let I'll draw it in the so it looks like this. A, B, C, D. Okay. E, F, G, and H. Mm, one. So this is the four. We have to find the cluster density of the four node cluster. So if you look at A, what is the fraction of A that is within this? So this is one cluster. This is another, and this is another. So for A, what is the fraction of friends within the cluster? That is one. So uh, all of its friends are within the cluster. For B, all of its friends are within the cluster. For D, all of its friends are within the cluster. For C, what is the fraction of friends that is within the cluster? So C has three friends, out of which two are within the cluster. So it is basically uh, 2 over 3. So the cluster density, so you have two friends that are within the cluster and one friend outside the cluster. And cluster density is the minimum uh, density for each of minimum fraction of friends uh, that they have within the cluster. So all these nodes A, B, C, D have at least two-third friends in this cluster. So all of them have at least two-thirds. So this is the cluster density of this node, of this cluster. So this is two-third. Similarly, for uh, if you look at E, it is two-third the fraction of friends within the cluster. For if it is one, H it is one. Again for G it is two-third. So this would be two-third. And for I it is again two-third, and for rest of them it is one. So this is also two-third. So all of them have cluster density two-third. I hope that answers your questions. Question. Okay.
Excuse me, sir. Please repeat the same.
So what is cluster
Not
density?
getting.
So if
Yeah.
you look at this cluster A, B, C, D, okay, so what you compute is the fraction of friends of each of these nodes in the cluster. So fraction of, if you consider node A, how much, what is the fraction of its friends that are within the cluster? So friends of A are B and D, which are within the cluster. So it doesn't have any friend outside the cluster. So the fraction of its friends within the cluster is one, basically. You understand why it is one?
Yes. Yes,
Hello?
sir.
Yeah,
How,
so
how,
so like that, if you compute
how
for
we are
B,
getting 2 by 3 for C node.
so for C, C has a friend outside the cluster as well, E, and it has two friends inside the cluster, B and D. So
Okay.
there are two-third of its friends are within the cluster and one-third outside the cluster. Is it clear? So you, when finding cluster density, you take the minimum fraction. So what we can say about this cluster ABCD is that each of these nodes have at least two-thirds of their friends within the cluster. So that is the cluster density.
Sir, I can't explain this sum, sir. Can you explain me one more time, sir?
So so you find, for to solve this problem, you have to find the fraction of friends of each of the nodes in the cluster. Okay, so if you take this cluster A, B, C, D, so they have told they have this four node structure. So they have segregated, they have already told which are the clusters. So A, B, C, D, one cluster, E, F, G, H, another cluster, I, J, K, L is another cluster. They have segregated into three clusters. They have already mentioned. Now what we do for in each cluster, we find out what is the fraction of friends within the cluster. So for A, it is 1. So A has all his friends within the cluster. B has all his friends within the cluster. D also all his friends within the cluster. For C, it has one friend outside and two friend inside. So it is two-third. So we can say for this cluster ABCD that all the nodes have at least two-third fraction of their friends within the cluster. So that is the definition of cluster density for this. And if you compute in a similar way for all the other nodes, it comes out to be two-third.
Excuse me, sir. Excuse
Yeah,
me, sir.
yeah. Go
If
ahead.
there is at only one cluster, then how will compute the same cluster
So
density?
so if there is only one cluster, cluster density is one. So first they will have to mention the cluster. So if this all the four this from A to IJKL. So from A to L, if all the nodes they have mentioned that they
Excuse me.
together.
Excuse me.
Yeah, go ahead.
Just for example, if we are taking if there is no connection C to E node,
Yeah,
then what will be the cluster density of a first graph?
it would be one.
It will be one.
Yeah,
Okay.
all the friends
Uh,
have their friends within the cluster.
yeah, it means we are taking inside the total number of friends of a node and outgoing from
Yeah,
the one cluster to another cluster,
right,
and divide by total number of friends. For example, C is taking two friends within the same cluster C1, and one is outgoing. It means there are three friends. It means two inside, and total are three, 2 by 3. Density of the cluster is 2 by 3. Is it
right.
right?
Yeah, you are right.
Okay, sir. Thank you. Now
Yeah.
I am getting this. Thank you, sir.
Okay, so if anyone has any other doubt regarding this question,
No doubt, sir.
okay, so let us proceed to the next question. So if the payoff of watching documentary and listening to songs is 0.5, 0.4, and four of your friends decides to watch movie and six to listen to song, which one should you pick? So you do like this. So you have documentary and songs. Uh, so you have this payoff that is for 0.5 and 0.4 number of friends who are
Answer will
watching
be
doc.
was the documentary, sir.
Yeah, so I'll just solve it for others. So four friends
Yeah.
watches documentary and six watches
Yeah.
six listens to song. So which one should you uh, pick? So net payoff here is 0.5 into 4, that is 2, and for songs is 0.4 into 6, that is 2.4. So this is higher. So the net payoff from for listening to songs appears to be higher than payoff for watching documentary. Therefore, it is likely that you will go with listening to songs. Which one should you pick? So this is how the decision model is framed. So you have payoff, you have number of your friends, and you just take the net payoff and find which payoff for which activity the payoff is higher, and you choose that activity. Coming to question number 9, cascade cannot be complete in a network with a threshold adaptation of Q if there exists a cluster with density. So what does cascade completion means? So cascade cannot complete. It means that there are set of nodes which did not adopt the idea, which did not adopt idea. So if a cascade was complete, it means that the entire network would have adopted the idea, but it did not happen. So there is a set of nodes which did not. We consider this as this cluster. Now let us take a node within the cluster. So let us take this node, and on the right hand side of it, let us say the on the right hand side are the nodes that belong to the cluster to which this particular node belongs. So let us call this node V. And on the right are the nodes that belong to the cluster which did not adopt the idea. And on the left are uh, its friends which adopted the idea. Let's say it has p friends who adopted the p fraction of friends adopted and 1 minus p did not adopt. So did if idea was not adopted because p was less than q. This is what q is the threshold and p is the fraction of friends that adopted. So if p is less than q, the idea won't be adopted. So 1 minus p should be greater than 1 minus q basically. So what is 1 minus p? 1 minus p is the fraction of friends in cluster. So which is basically greater than 1 minus q. So the cluster density should be greater than 1 minus q, in which case the cascade cannot be complete. So option D is the right answer for this question. Okay.
Excuse me, sir.
Yeah, go ahead.
Sir, I have put 3 questions similar to cascading. Could you please check it in the chat box?
Okay. Let me share it with you. So given a network as shown in the figure, assume that initially every node in this network has adopted behavior B. Next, a new behavior A is introduced, and nodes V and W are initial adopters of behavior A have now adopted, and the rest of the nodes have adopted B. The payoff associated with A is 3, and the payoff associated with B is 2. After the introduction of this new behavior in the network, all the nodes will start weighing their options and might change their behavior, which leads to a cascade in the network. After 2 iterations, which nodes uh, would have adopted the behavior A? So behavior of A is 3 and payoff of A is 3 and B is 2. So if we look at node R, node R has 2 friends V and W which have adopted the new idea. So it's 3 into 2, that is 6, and S is adopted B. So it would be 2 into 1 2. So R after first iteration R would have adopted uh, the new idea A. Coming to S is only influenced by R. So in the first iteration, S will not adopt the new behavior A. So S will remain with behavior B. If you look at T has one friend V and one friend U. So for T, since the payoff of A is more than payoff of B, so T will definitely adopt behavior A after first iteration. For U has 2 friends with new behavior and 1 friend T with old behavior. That is similar situation like R. So you will also adopt new idea after 1 iteration. And now after 1 iteration, only S is left without adopting new idea. In the second iteration, S is connected to R, which has already adopted new behavior A. Therefore, S has no choice but to adopt. So after second iteration, all of them would have adopted new behavior.
So, but the answer in the answer key, option B is correct.
Option B is correct.
Option
Means
B, EWTS.
so they are saying that U and R did not adopt.
Yeah, I was also confused with this. How it is possible? Like,
But if you do the weighting, so R for R, the if you take the net payoff for idea A would be 2 into 3 because two of its
Yeah.
friends, so that is 6 and this is 2 into 1. So R would definitely have adopted after first iteration.
Yes, sir, exactly.
I think all of them would have
Yeah,
adopted
yeah.
after.
But in the
Like,
answer, the option B is given. I guess that
yeah,
is wrong.
yeah, I think that's okay. Coming to the next one, consider the following network with green nodes following the action A and red nodes following action B at time t equal to 1. So the payoff of action A is 6 and B is 5. Each one in this network changes his or her reaction based on his or her friend's action. What will happen after one complete iteration? So there are only two nodes with uh, with action A and rest with action B. So for which nodes, if you uh, uh, consider node um, uh, 0, so 0 has only two nodes. So if you consider node 4, so for node 4 what happens is that it it will get influenced by node 0. So node zeros uh, payout, so it is mentioned that each one in this network changes his or action based on a friend's action. So the for node 4 it will definitely change to the red action, that is action B after one iteration. For node 7, for okay, so for node 1, so for node 1 again it will also be influenced by all its neighbors which are red, and it has no neighbor which is green in color, so it will eventually become red itself. But if you consider node 0, it has two green and I think one, two, three, four, five reds. So five reds will outweigh the two greens. So 2 into 6 is 12 and 5 into 5 is 25. So 0 won't change its action. For node 7, on node 7, it has one node, uh, one green connections and four red connections. Again, it would be 20 versus 6. So 7 would remain red. So eventually all will adopt this red actions. I think this is.
So, but the payoff for red idea is 5, right? So, doesn't the payoff matter here?
Yeah, it matters, but they are forming this cluster, no, that is of high density, such that the cluster density, the threshold to penetrate this new action into this cluster is very high. If there were
Okay.
more number of greens that were connected to each other, then perhaps this would have infiltrated. But
Okay.
here it is not happening.
Okay.
Okay, so 1 minute just to revise this question that you asked previously. So
Yeah.
here, I think what happens is that when we look at this cascading model, we once a new idea is adopted, we don't consider that it can be replaced. So what we did not consider in the last explanation was that V and W's can also change. So what would happen? So let us revise once again. So in the first iteration, like I said, that R would definitely get converted to behavior A, S would remain at behavior B, T would get converted and U would get converted. But we did not look at what would happen to V and W. So for V and W, what would happen is that if you look at the friends of V, so it is R, T and W, what would happen is it has 2 into 3. uh, so 1 into 3, that is coming from W, and 3 of his friends are with the old behavior, that is A. So sorry, that is B. So that is 2 into 3, that is 6. That this is the pair for the old behavior, and 3 into 1, that is for the new behavior, that is from W. So we will actually change to uh, B. V's behavior from A will change to B, because after first iteration, because 3 of his friend R, T and U are with the behavior B, and therefore V will change. Even though R, T, U themselves have changed, we will, by looking at R, T, U, V itself will change to the old behavior, and W would, and similarly for W, the same thing will happen, that 2 of his friends R and U are with the old idea, so 2 into 2 is 4, and one friend with new idea, that is V, so 3 is less than 4, so W will also change to uh, idea B. And then in the second iteration, if you do, then you will see that again, due to influence from R, T and U, V will again change back to V, and W will change back to this new idea B, whereas S, if V and W will change back to A, and and T will change back to A, and since R has adopted A, so S will change back to A, but R and U won't change back, because in the after first iteration, V and W were with behavior B. So R, in the second iteration, R and U will adopt behavior B. So R and it will like alternate, it will keep on alternating. So option B is the right answer. Did you get
Yes, sir, got it.
the, yeah, yeah. Okay,
Excuse me,
so
sir.
yeah, go ahead.
We have last question. I have shared in chat box.
Uh, okay, so Havel Hakimi theorem, which of the following is a valid geographic sequence? So I don't know about this Havel Hakimi theorem. Does anyone else know about this? So I haven't studied about this Havel Hakimi theorem. Can anyone else help him with this question?
This question was asked by NPTEL discussion forum, sir.
But
But there is no concept of Havel-Hakimi theorem in our video lecture.
yeah, I haven't come
we
across myself.
Sir,
we
it's
have
like
heard
we have to
about
remove the
this
first,
new
we
new
have to keep
concept.
on removing the first element, sir, and arrange in descending order, sir, like non-increasing order, and we have to minus 1 from the first element. If every element becomes 0, then it is called as the same number, sir.
But in our video lecture, there is no concept of a Havel theorem.
I think we'll have to skip this part. So I don't think this is related to like uh, any of the assignments. Does any of the assignment mention this Havel Hakimi
No,
Sir,
sir,
theorem?
this
no.
question is out of course.
No, sir.
No.
No, sir. No, sir.
Oh, okay, then we can skip
This
this.
question was asked by NPTEL
Okay,
discussion
maybe,
forum,
but
sir. Not
maybe,
part of any assignment, not part of any video lecture.
Okay, so I personally don't know about this theorem, so mm, I think we'll have to skip this.
But as I think these type of question may be asked in our examination, sir, on 29th of April.
But if it is not in the syllabus, why will they ask you such question?
As I
Like,
think such type of question should not be asked
yeah, they,
unrelevant of our study
yeah,
material video lecture.
I don't think this is related to the course, so they won't ask, hopefully. So you can raise a complaint if they ask in that case.
Okay, sir. Thanks a
Yeah,
lot.
yeah. So there is
So,
one more
yeah,
question that is related to this
yeah.
clustering.
But
I
sir,
think,
we have raised a lot of complaints during running courses, but they have accepted also, no issue.
okay,
Like for example, in assignment number 3, concept of the betweenness, they have set the wrong answer key. We have already had the raised already queries about that, but they have not accepted that at that time.
okay. So that part I can't help you with. I am not
Yeah.
associated with help. Like,
Okay.
yeah,
Okay.
yeah.
No issue, sir. No issue. Even though we have scored a very good. Uh, it means grades in our internal. I have got 22 marks about out of 25.
Okay, okay. That's nice.
Yeah. And
Okay.
hoping we will get good also in final examination, sir.
Yeah, yeah. You will get good
Yeah.
marks.
And thanks a lot to you, sir,
Yeah,
for
yeah.
helping.
Uh, yeah, yeah.
Yeah.
My pleasure. Coming back
Sir,
to
I have a
the,
doubt.
yeah, just let me finish this
Chat box
discussion.
given sir. Density sum I have a doubt, sir. In chat box it is there, sir.
Yeah, yeah, I'll address it. So I have opened one question. I'll finish addressing and go back to that density one. So in this question, given a network as shown, so network is in the next figure, I think. So assume every node in the network adopt behavior B. Uh, Next, a new behavior A is introduced in nodes M and N. They are initial adopters of behavior A. Payoff associated is 3 and 2. Further, after the introduction of new behavior in A, all nodes start weighing their options to change their behavior, leading to cascading. So after 2 iterations, what will happen? Who would have adopted A? So I think this is similar to the first question that is asked, but I think one edge is missing between Q and N. So this is like the one that you just asked, the first one
Yes, sir.
with. So here also, I think the same concepts will be applied, and once they will adopt and they will again go back, and something like that would happen. I think you can work it out in the same fashion. Since we are little short on time, uh, I hope you can do it on your own, like
Okay, sir.
similar to.
But the answer key for this is option number 4. So it is quite confusing what to do in these cases.
Okay, so let me go. The payoff association further after introduction will now start weighing options to change, leading to cascading in the network. Uh, okay, here they're saying that all of them would have adopted. So, okay, so what would happen after 2 iterations? So M and N got the new behavior. So M and N for Q would have adopted M because it's only connected to M. R would stay with the old behavior. N is new behavior. O would uh, go back, go take new behavior because it's a new behavior's payoff is more compared to old behavior. For P, it has two. new behavior, one old behavior. So obviously P will take new behavior. So only after first iteration R is left out with old behavior. Uh, Now after second, but what about M and N? So for M and N, Q is old behavior, N is new behavior, and P is old behavior, and O is. So after first iteration, M will go back to old behavior, and uh, e- N sticks to new behavior. N does not go back to old because N observes M. So M is new behavior and P is old behavior. So payoff of so it has only two friends. So payoff of new behavior is more than payoff of old behavior. So N sticks to new behavior even after first iteration. So after first iteration, M changes to old behavior, R remains at old behavior, and all of them are new behavior. In second iteration, what happens is that M all of M's friends are new behavior. So M becomes new behavior and R becomes new behavior because R is connected to Q, which is new behavior. So all of them will become new behavior. So in this case, option would be, I think, 4, where all of them becomes new behavior. The only
Okay.
difference with the previous question is the link between Q and N is not there. So in the first
Yeah.
problem, N was going back to old behavior after first iteration, whereas here it is not going back to old behavior.
Yeah. Got it, sir. Thank you. Thank you so much, sir.
Yeah.
Can we leave, sir? It's enough, as I think.
Can you
Okay.
discuss the density sum, sir?
Okay, I'll discuss. So those who want to leave, you can leave. I'll discuss the density questions.
Okay, sir. Okay. Okay, sir.
Yeah, yeah.
Thank you.
The density question. So this is the question that you asked.
Yes, sir.
So what is the density of the graph? So you have 5 nodes. So total number of edges that can be present is 5C2, that is 10. And how many edges are present? That is leaving 2. So 8 out of 10. So 8 by 10, I think, should be the density.
Sir, but in solution, it is given as 8 by 15, 0.53 as the answer, sir.
8 by 15.
Yes, sir, 8 by 15, sir. In solution, assignment solution, it's given, sir.
Okay.
Sir, that
But
answer key is wrong.
I guess so. So because
Yeah.
maximum edges can be 10, right? You have 5 nodes.
Yeah, there is
Yes,
no
sir.
way
That
that
only
could be
doubt I'm
15.
having.
Yeah.
As I think there is a wrong something in this question, sir.
Okay. Yeah. Hopefully, I think it is 8 by 10. So you basically, to calculate density, you find total number of edges present and maximum divided by maximum number of edges that could be present. So it is 8 by 10.
Yeah. There are 5 nodes, sir. 5C2, and
Yeah.
edges are as I think 10, 10, sir, total.
Yeah. Total. So here in the graph, there are 8 edges. And
8 edges, 8 by 5C2, sir.
yeah, so that is 8 by 10.
Yeah, 8 by 10. So answer is wrong in this case, sir. I have checked this question.
Yeah. Yeah, right.
Yeah, answer will be 8 by 10, sir.
Okay. So leaving this, so let so I have few more questions left. I'll just go through them quickly. So it won't take much time. If you have any doubt, you can stop me and ask, but I'll just finish it quickly. So if a Markov matrix A whose eigenvectors and eigenvalues are v1, v2, lambda 1, lambda 2, and respectively is applied on a vector v repeatedly k times, which of the following is true considering we keep normalizing the resultant vector after each iteration and lambda 1 is the greater eigenvalue. So what would happen is that if you keep multiplying a to the power k. So it would, option A is correct, is the right answer, where it will a to the power k v1 k v. So this v is any random vector and which you keep normalizing. So it would eventually converge to v1, that is the eigenvector corresponding to the highest eigenvalue. So option A is the right answer. Coming to question 5. So which of the following is a property of a Markov matrix? So uh, the largest eigenvalue is 1. So the right answer for question 5 is C. So this is the Markov property. So the smallest eigenvalue, you need not bother about what the smallest eigenvalue is. All eigenvalues are less than or equal to 1. So D is part is not fully correct. So they are saying that it's less than 1, but it should be less than and equal to 1. And the large, there will always exist a eigenvalue with 1. So the largest value eigenvalue is 1. Coming to week 9, in a random graph with 500 node and edges between any two nodes with probability 0.27, where can one expect the peak? So this is the Erdos Renyi model. So where the it looks like this. So you have degree could be 0 or maximum can be 499. This is degree. And it is a normal distribution whose peak is the mean of it, where the peak will occur. So this red part is actual degree distribution that you see, but the if you extend it, it would be a normal distribution, and this peak is where expected number of degrees, expected degree. So expected degree is basically the probability expected degree of each node, which is basically the probability with which the edge is added and the maximum number of edges that a particular node can have, that is 0.27 into 499. This is around 135. So this is the right answer, option C. Okay, so in the given graph, a new node X is introduced. What is the probability of a node being attracted to either A, B, or D, given that X makes only new friends? So here it follows the preferential attachment, preferential attachment, in which case what we find out is that we find out the degree of each node, and X attaches itself with the node having the highest degree. So the degree of A is 3, degree of B is 2, and degree of D is again
3.
3. So the total, so and if you take the total degree, it comes out to be 30. So the probability is
30.
basically 3 over 30 plus 2 over 30 plus 3 over 30, and that is 8 over 30. So this is how you find out the probability. Okay, so coming to week 10. So in the branching process, the reproductive number if the disease persists in the network. So in a branching process, you have one node and it has k children, and each k each of its children again has k children, and this continues like this. So reproductive number is the ratio R naught is basically P into K. So K is the number of children that each node has, and P is the probability with which the disease transmits from one node to other. So this is the expected number of children to be affected of a particular node. So it what happens is that for if you go to the ith level, the number of affected nodes is equal to expected number of affected nodes is sorry, pk to the power I, and this will, and in and to for disease to persist, this must be greater than, this should not go to 0. So for disease to persist, when I increases, this pk to the power I should not go to 0. So when it won't go to 0, if it is greater than 1. So the right answer is greater than 1. So which of the next question, in which of the following models can the disease stop spreading? So in SIS models, one node can become susceptible, get infected, and again recover and become susceptible. So in SIS model, the disease can keep on spreading, but in SIR model, if a node acquires a disease and gets recovered or removed from this network, it does not spread the disease anymore, or it does not acquire the disease again. So in SIR model, the disease won't spread. So option 2 is the correct answer. Coming to week 11, so which of the following option best describes the small world effect? So in a small world effect, it has two components. One is homophily, that you are friends with people near you, and you have some friends that are far away from you. Those are weak ties. So it's two concepts, homophily and weak ties. So for that, what the most relevant answer is that any two people are friends in the world. This is not true. Most people are isolated. That is also not true. And option D, friendship network representing the world is small. That is also not true. So the option C is the right answer, where any two people are connected with a small path line, that is average around 6 from the Milgram's experiment. Coming to the next question, which of the following is false? Again, in a small world effect. So like I said, it has two components, homophily and weak ties. Every two people are connected with a path. This is not correct. The average path length between any two people is uh, is false. Okay, so what they're saying, that which of the following is a false. So every two people are connected with a path. Yeah, they may not be connected, they may not be immediately connected, but there always exists a path between any two people, because a small world forms a connected network. So option A is correct. Average path length is 6. That is also correct. People only from friendship within their neighborhood. Now this is homophily, but not weak tie. So this option is not correct, and we can attribute this phenomenon to weak ties and homophily, which is by definition. So D is correct. So option C is the right answer, and C is the only false option. Okay, so again, coming to question 6, next question. So RAM creates a graph in a 2D lattice and rewires these edges with this probability 0.02. What would be the average path length? So it makes a 2D lattice and connects nodes that are adjacent to each other. So this part is homophily, and this rewiring is formation of weak ties with this probability. So what would be the average path length? So this type of experiment falls under Watt-Strogat's model, and in most cases, what would always appear that this path length is, average path length is 6, irrespective what this probability 0.02 is. So the right answer is option C. Coming to week 12, so a subgraph of a graph is known as a k-core if each node has a degree greater than or equal to k. Option D is the right answer. And next, the time complexity for myopic search in a small world network is, it has been seen that it is O of log n. So it is like something like this. So you increase n, and this is time complexity. So the time taken to maybe deliver your letter from one node to any other node in the network, and if you increase the size of the network and you plot it, it looks something like a log n curve. So O of log n. Coming to 9, so this is, I think, the last question. So what are the number of nodes in the one code? So what you do is you first create this bucket 1, where you pluck out all the nodes which have degree 1. So you pluck out A, you plucked out A, and you remove this edge 2F. you pluck out D and remove. So you in bucket 1 you have removed A and D. So now F degree is 2 and all the other nodes degree are greater than 2. So for the 2 core, so this forms 2 core. Now if I now but they want what is 3 core. So what I do is from the second bucket and I pluck out F. So I plucked out F and I cut off these. So now B's degree is still 4 and E's degree is still, so B after plucking out B's degree 4, E's degree 3, C3, H3 and G3. So this forms the 3 core. So I remove only A. So the number of nodes in the 3 core are basically the inner nodes. So B, C, E, G and H. So there are 5. So option B is the correct answer. So okay, we have one more question. So which factor has the most correlation with influential power of a node? So it is seen that coreness of a node has the highest correlation with influential power of a node. So that was all the discussions that we had. So there are a few more questions I can see in the chat box. I'll take
Excuse me,
them.
sir.
Yeah.
Yes, sir. Sir, could you please go through chat box once, like in 5 minutes? Could you please tell us the answers for that?
Okay. Right. Mm,
Yes, sir.
okay.
From this question.
Let G be a set of 5 graphs generated using Erdos-Renyi model while considering the same parameter. Let H be a set of 5 graphs generated using the Barabasi-Albert model with the same parameter for all the 5 graphs. Which of the following? Okay, so average degree of all graphs in G is same. Average degree of all the graphs in H may vary. Average degree in H is same. Average degree of all graphs in G is same. The same. Average degree of both varies in each iteration. So what uh, in Erdos in this Erdos-Renyi model, it is seen that the average degree of all the graphs in would the option A is the right answer, where in G it is same and in H it varies because of preferential attachment. And for G it would always be this normal distribution whose mean you can always compute using that probability into the maximum number of degree that can be calculated. So the average would remain the same for the graphs in G, whereas for H, it will vary based on the preferential attachment that happens.
Okay, sir. Thank you.
Okay, so we have next. Let the number of atoms in an unexplored universe be 10 to the power 80. What is the smallest number of nodes such that the number of possible graphs on that many nodes is greater than or equal to the number of atoms in the explored universe? So this is, I think, like this. So what is the smallest number of nodes is that the number of, so you, for this possible number of graphs, so you go to this first question that I discussed. So if you have 50 nodes, the possible number of nodes graphs would be 2 to the power of 50 C2. So that would be the possible number of graphs, and you put these values in this. I think you'll have to do some computation to check. So this is the formula for the maximum number of graphs that you can generate. So you take n to be something that is the smallest number of nodes, and from that many nodes you get 2 to the power nc2 would be the maximum possible number of graphs, and for that it should be greater than 10 to the power 80. That is the answer.
Okay, sir.
Okay, so coming to the next one. Okay. Which of the following is not possible in the gold coin distribution game? Total number of coins in the system decrease. One node ends up collecting all the gold coins. One node ends up getting no gold coin. Total number of coins in the system increase. Which of the following is not possible? So A and D are not possible. So the total number of coins in the system will remain the same. So neither increases nor decreases. And B and C can happen.
Okay, sir. Got it.
Okay. Okay, in the percolation model, it is possible to find a node will be infected or not without any notion of time. When can you say that a node A is susceptible for infection in a percolation model? If there exists at least one path with all open edges from the infected node to node A, if there exists at least one path uh, with one open edge with one open edge from the infected node to the node A, if there exists more than one path with one open edge from infected node A, if there exists at least one path with all closed edge. So I think if there exists at least one path with all open edges, so the option A is the right answer, because if in that path, if there is one closed edge and one open edge, then the infection won't percolate. So all the edges have to be open. In there should be a path where all the edges are open, so for the infection to percolate. I think option A is the right answer.
Okay, sir.
Yes, sir. That is right, sir.
Yeah, okay. So let log2 be 3.3 and the number of atoms is this. Pick the number of nodes from the below given after that the possible graphs on that node is similar or equal to the number of atoms in the explored universe. So you'll basically have to this is like the same problem. So you
Yes,
have
sir.
to
Yes. Got it.
you can do that. Okay. In a Facebook network, a link represents reciprocal communication. If a user followed information about a friend at the other net end of the link, whether or not actual communication, if the user both send messages to the friend at the other side of the and also received from them during the observation period, the user sent one or more message on the other end of the link, whether or not so I think option B is the correct. So if you send reciprocal communication means you send something and you get back also something. So uh, in the first one it is a directed graph, in the third one also it is a directed graph. So if for reciprocal communication to happen, so both of them has to send messages. So you send a message to your friend and your friend also send back you a message. So that is reciprocal communication. Option B, I think. Is there any doubt?
So in option B, there is no reply from the other end, right? So how can it be reciprocal?
So option B says the user both send messages
Okay, both
to,
send messages.
yeah,
Other side.
on also received messages from them.
But so both different users sent a message to another friend, right? So there are three
So
people in this.
no, what both signify is that the one of them send messages to the other link and received back message. So these two things they are combining in both.
Okay, sir.
Yeah.
Got it.
Okay. In a graph G where nodes represent words in a dictionary and there is an edge between two nodes, if two words are similar, synonymous, then choose the correct option according to the given string. The graph is connected. If a word is connected to B, A is connected to B is to C, and then A is synonymous to C. So the answer is statement 2 is correct, because if statement 1 cannot be correct, it means that every word is similar to every other word, it would mean. So that is not the case, right? And
So, but if the graph is disconnected, then how can the second statement would be true?
if A is connected to so A, B, and C could belong to the same connected component, and other part can be a different connected component.
Okay, sir.
So
Got it.
yeah, Coming to the next one, the core number of a node cannot be greater than its degree, lesser than its degree, equal to its degree, can't say. So the right answer is greater than its degree. So core number, so how you get the core is by removing the nodes with lower degrees first. So it would you basically keep reducing the degree till you reach the k core. So it will always be the option A cannot be greater than its degree.
Okay, sir.
In and second one, given that a node in a network is part of exactly 3 clicks, so complete subgraphs of size 3, size 4, size 6, given that a node is a part of exactly 3 click, then the core number of this node cannot be. So it is part of uh, so of so it belongs to 3, size 4, size 6. It cannot. Then the core number of this node cannot be. Wait, it cannot be greater than 3, less than 7, less than 6, and less than 5. So if it is greater than 3, so it belongs to, therefore option 1 is correct. It cannot be great. Option 1 is correct. It can be greater than 3 because uh, in the no, option 1 cannot be correct because of size 3. So greater than size 3 means the core size is 3, size 4 core size 4, and size 6 is core size 6. So in option 1 it cannot be greater than 3, it would be always less than 3. Option 1 is not correct. Less than 7, yeah, it is less than 7, less than 6, less than 5. Yeah, so option 1
So,
is
but if it is less than 7, 6, and 5, then it would be greater than 3, right?
uh, wait, you're right. um, mm, it can be greater than given that a node in a network is exactly part of 3 clicks. So
So I
I
think
will,
in these options are wrong because it should be
yeah,
greater than 7 or either greater than 6.
right. So the code number of this node can be, so what would happen is like this. So if I go and draw the figure, so okay, so what happens is this is, so what is this size 3, size 4, and size 6? Wait, that this is what you asked, right? uh,
Yes, 3, 4, and
and
6.
it belongs to all 3 clicks. So it it is somewhere here, it's inside this 6. So then the core number of this node cannot uh, can be 7 less than, so it cannot be less than 6. So the core number cannot be less than 6, I think, is the right answer. So any node that is within this innermost ellipse will have core number of 6 or greater than 6, right?
Okay.
So this is how the cores look. So 3 is the bigger one, 4 is within 3, and 6 is within 4. So any node within 6 can have core 6, can have or 7 or 8 or 9, but not less than 6, right?
Okay. So then
Yes.
what about option number B? It says that it cannot be less than 7.
So that is not correct. So it can be 6. Uh, option, it cannot be less than it can be less than 7, right? Node with core 6 can exist over there.
Okay.
And option A is also correct in that way, greater than 3, but it is not fully correct.
Okay.
So less than 5 won't be correct. Less than 6 won't. So less than 6, I think, is the right answer. That is what they're looking for.
Okay.
Yeah. Okay. You have other questions? So what would be the output of the following code? So I equal to 2 while true if I is not remainder of I when divided by 3 is equal to 0, break. So print I, else print I you increment by 2. So initially it was 2, so you print 2, then I became 4, again you print 4, then you uh, uh, it while true I is 2, then it's break. But after getting to 6, when it gets to 6, it already leaves the while loop, right? So this statement is print is within the while loop. So I think it should print only 2 and 4.
Yeah, 2 and 4 should be right.
Yeah, I think 6 won't be printed.
Yeah.
Two reasons. Two reasons why imitating the behavior of others can be beneficial. Uh, Direct benefit and observe information and innovation benefit, information direct benefit, compatibility and complexity effect by the behavior. So one is information, that is right, and I think is C the correct answer, the direct benefit.
I think so, but the answer key for this is not available, so I'm not that sure.
I think this is right what you're saying, information and direct benefit.
Yeah. Okay.
Okay. According to power law distribution, the fraction of web pages that have k links are proportional to 1 by k2. What is the exponent? Is between 2 and 3. So C is the right answer. Between 2 and 3.
Okay, so but in the video lectures, the sir has told that it is,
It
I think
it's
it is,
more closer to 2, but it's not exactly 2. It is
okay,
around 2 and 3.
okay.
Yeah, so according to the lecture video, the news list and good articles are the examples of hubs and authorities. So news hubs and authorities, hubs points to authorities. So news points to good articles. So hubs and authorities respectively.
Okay.
Uh, Okay, so I think this one I have missed. In a World Wide Web, let N1 represent the number of nodes having the least degree, N2 the number of nodes having the highest, and N3 represents the nodes having the median value of the. Choose the correct statements. So N1 is least degree, N1, N to represent the number of nodes having the. So this is a Barabasi-Albert model. So N1 with node having the least degree would be the highest. N2 is the number of nodes having the highest degree, that would be the towards the tail of it, and N3 is the median value of the degrees. So it would N3 would lie in between. So N1, N3, and N2, that sequence.
N1,
So
N3, N2. Okay.
yeah, this 4, option 4.
Okay.
Okay, and consider a group of 10 bachelors, 5 live on first floor and 5 on second floor. Suppose that each person in this group has 2 friends on their own floor and one on the other floor. Now, a new restaurants open and 5 persons all living on the first floor each begin eating there on the first day. This action will eventually be adopted by uh, so they have said that each person in this group has 2 friends on their own floor, and so all 5% on the first floor starts eating. So in the other floor, in the first iteration, the other floor members will obviously get influenced by the friends in the first floor, because there is always, but you can't always say that. I think the option would be can't say, because if they have uh, each person in this group has two friends in their own floor and one on the other floor. So uh, the uh, s- so for every person in the floor above, in the second floor, that has not been to the uh, new restaurant, so for them, will they adopt the idea or not? So two of its friends are sticking to the old idea, and one of them is going with the new idea of going to a new restaurant. But we do not know what the payoffs are. They have not mentioned the payoffs are, therefore we can't say. I think can't say would be the right answer, because you have to give the payoff of not
Yeah,
going to
yeah,
the.
yeah, right.
So
So, and in the previous question, can we say that N1 is equal to N3?
no, n1 n3 you can't say. It would be
Sorry,
like
N1
this.
is equal to N2. N1 equal to N2. Can we say that?
No, it won't. Like it is like this tail thing. So it would be something like it. Uh, so this is degree distribution and frequency. So n1 least degree is somewhere here. N1 is somewhere here, and so actually this is the node with the least degree. So let us call this A, and this is n1. Okay, okay. So the graph looks something like this. This is
Okay.
the. Wait, let me open that question. Which one was that? Uh,
Third last question.
yeah, third last question. So N1 represent the number of nodes represent the number of nodes having the least degree. So this is the A is the node with the least degree, and N1 is the number of nodes. Correct. N2 is the number of nodes having the highest degree. So this, let's say B is here, has the highest degree. So N2 would be somewhere here and represent the medium number of nodes having median value of degree. So median value of degree is around here, C. So it would be higher than N. So it would be actually N1 greater than N3 greater than N2. This is the Barabasi-Albert model. So I think what I said was wrong. Uh, it
So,
should
but it
be.
is asking about the number of nodes having the
So
degree. So
yeah,
the
so
number of nodes,
so this is the, let's say A is the node with the least degree, and
yeah.
N1 is that many number of nodes that have degree A. You get
Okay.
it? So
Okay.
it
So
looks
I will
something.
revise again. No issues.
Yeah, so A is the node, is the least degree in the graph. So A has n1 nodes, C is median, and B is the highest. So it's a decreasing graph. So it would be n1 greater than n3 greater than n2, I think.
Okay, so got it. So
Yeah.
one more last question. So
Yeah.
if person A chooses idea A, which has payoff A, and
Hmm.
person B chooses idea B, which has payoffs B,
Hmm.
then how will we calculate the payoff at last if both chooses different ideas? It be 0 0, or would it be
Oh,
correspondingly like A
so
and B?
you're saying A and B are connected.
They are friends.
Okay, so A chooses idea small a, and let's say b, it has zero point 0.4 and it has zero point 0.5. So what would happen in this case, right?
Yeah.
So in this case they will keep flipping, like according to that cascade model that we discussed, A will choose initial in iteration 0, A chooses A and B chooses B. In iteration 2, A will choose small b and B will choose small a, because A is only getting influenced by B and B is only getting influenced by A, and it will keep flipping, so it won't converge.
So, but the options are A is equal to A, B is equal to B, A is equal to 0, B is equal to 0, A is equal to
Then
0, B is equal to B, and A is equal to 0. Sorry, opposite to that.
so if A and B are equal, what, like, can you repeat the question once again?
Not actually, they're not equal. Means the payoffs are A and B only. They have not told any number of payoff.
And what happens at the end?
They chooses their respective ideas A and B, and what will happen at the last, like in the question that is asked. Will it be 0, 0 or respective payoffs A and B?
So it will remain the rest, like payoffs don't change in the iterations, right?
Okay. Okay, so but in the lecture videos that ma'am has told that if you choose another payoff and your friend chooses another payoff, then you won't get any points. Like it would be 0, 0. So I'm confused with that.
Okay, so I am not sure about that. I think then you'll have to check that lecture. I'll have to see that.
Okay, sir, no issues. I will revise.
Okay.
Sir, thank you,
Mm,
sir.
Yeah,
I'm
yeah,
really sorry for getting you this late, but you have
yeah, yeah,
explained really nice. Thank you so much, sir.
yeah. All the best for your exams.
Thank you so
Okay.
much, sir.
Yeah, I think we can close the session now. And
Yeah.
yeah, all the best everyone for your exams. Tomorrow, I think there will be one more tutorial session. You can attend it as
Yeah,
well.
yeah.
Mhm. Mm,
Okay. Thank
Thanks
you
a
so
Yeah,
lot,
much.
sir. Thanks a lot. Thank you very
yeah.
much, sir.